of these changes. So firstly, we have a sin x graph. All right. So I'm going to start off by drawing the mother graph and make each change step by step. Okay. So sin x, how does sin x look like? Okay. Sin x looks something like this, where let's do that, and then we can draw it equally. Okay, sin x looks something like this. This is the mother graph. Okay, actually, okay, sorry, let's just draw it a bit smaller. Okay, this represents sin x, where its maximum is 1, its minimum is -1. Okay, its maximum is 1, its minimum is -1. Its first turning point is at 90, intercept 180, turning point 270. Okay, and then intercept again 360 degrees. Now let's make the first change to this graph. Let's change this graph to 2 sin x. So now we're going to draw 2 sin x. So remember the number in front of sin x, what it does is you take the old maximum, which is 1, and the old minimum, and you multiply it by that number. Here we're going to get 2, and here we're going to get -2. Okay, so the first change is that we're going to make it 2 sin x. So now in this case, the maximum is 2 and the minimum is -2. Okay, of course, in your exam, you're not going to firstly get a question with so many changes. Okay, because obviously, like in this, I'm just doing this example to teach you the different types of changes. Okay, so we can go through them all at once and see how they work. Right now, the other thing is you also what you can do if you're asked to draw the graph is initially draw your mother graph. So just like how I'm drawing this graph and this graph, okay, you can initially draw your mother graph. Okay, eventually we'll gray it out, right? But you can draw your mother graph in pencil. Okay, draw a dotted line or draw anything you can do. Just say there's 2 changes to that sine graph or that cos graph. Draw your mother graph, make one change, make the next change, and then draw that final one bold in pen. Okay, so now we've made the first change. We have drawn 2 sin x. Okay, so we're just chipping away at all these changes. The next thing that we can do is we can make the period change. Okay, the period change is 3. So what we're going to do in that case is, how do we get the new period? We say the old period, 360, divided by that coefficient, which is 3. So the new period is 120 degrees. Okay, now 120 degrees, here we have 0. Here we have 90. Here we have 180. So 120 degrees is somewhere here. Okay, let's see, where would it be? If we divide this into 2, we're going to get 135 in the middle. So 120 is going to be somewhere here. Okay, I'm just approximating. Obviously, if you have like graph paper, then it would be more accurate. So 120 is going to be here. Now, this is going to be a bit of a weird graph for us to draw, but nevertheless, we're going to draw it. Okay, because it needs to be as tall as this, but basically, it needs to end at 120 degrees. Okay, so let's do this, so it doesn't come in our way. Okay, so those are our old graphs. Now, we need to draw this graph so that literally we need to, this entire graph, okay, this one here, this 2 sin x, we need to compress it all the way so that it ends at 120 degrees, because that's what this means, a change to the period. Okay, it actually compresses our graph. Okay, so let's do that. We need to keep the amplitude the same, number 1. Okay, and we need to keep yeah, okay, that is the only change we made so far, the amplitude. Okay, we need to make sure to keep the amplitude the same. So what I'm going to do is, this is 120 degrees, okay? I'm going to divide this 120 degrees into 4 equal parts, because that represents my step. Okay, 120 divided by 4 is, of course, 30. So to separate this into 30, 60, we can separate those into thirds. So 30, 60, that kind of looks right. Okay. and then 90 and 120. So now these are separated into my steps. Okay. Now remember, I'm going to start here because this is still my sine graph, starts at the bottom, starts at 0. Okay. And it's a positive sine graph, so I'm still going to go up. So the key thing is my first step gives me my turning point. So I'm going to draw a dotted line all the way up to there. Okay. So I know I'm going to have turning point. So at, let's label these 30, 60, 90, and 120. Okay. I'm going to have turning. Okay. We start off at 0, intercept, turning point, intercept. 90 is going to be turning point, and 120 is going to be intercept. Okay. Those 4 different sections of my graph. So I know at 30, I'm going to have a turning point. At 60, I'm going to have an intercept. And at 90, I'm going to have my next turning point. So I draw a dotted line down. Okay. And then 120, I'm going to have my final intercept. So I go up. Okay. And I go down to meet the intercept. Next turning point to intercept. Okay. And that's exactly what my graph is going to look like. Let's see if we can. Okay, get rid of as much as possible. Yeah. Okay, so this is our new graph. Okay, with 2 changes. We basically just made a period change and we made an amplitude change, and that's how it would look. Okay, please stop me if you don't understand anything and I can re-explain it, but so far I hope that this makes sense. Okay, so yes, the first change was to increase the amplitude all the way up, right? We made it 2 sine x. The next thing was to decrease the period to 120 degrees. So that literally means compress the entire graph, right? And you see the step. How do you draw it, right? How do you then draw it when now you have a period of 120 degrees, irrespective of what your amplitude is, right? You understand, okay, I need to start from 0. I need to end at 120. Then you separate it into 4 equal parts, okay? Because that's each step, right? From intercept to turning point, intercept to turning point to intercept. Okay, so I separated into 4 equal parts, and each different interval represented either a turning point or an intercept. And I obviously try and understand where I start off with an intercept, and I go to a turning point, intercept, and I draw it accordingly. Okay, let's make the next change. So this change is done. We have that change done. We have that change done, right? Let's move this 30 degrees to the left. Okay, we're going to move it 30 degrees to the left. Now, what's cool about a graph, okay, about a function, is that when you move any graph, okay, when you shift any graph, let's just say to the left or to the right, every single coordinate on that graph is going to shift the exact same amount. Okay, so for example, if we have 0, this coordinate, because when we shift it 30 degrees to the left, is going to be negative 30. 30 is going to go to 0, 60 is going to go to 30, 90 is going to go to 60, 120 is going to go to 90. Every single coordinate is going to shift 30 degrees to the left. Now, of course, in this case, we only care about the coordinates that are relevant to us, and these are intercepts and turning points, right? So let's shift all of those values. Let's do this. Okay, so that's now our old graph, and I could literally also just copy this graph. I don't know if it's going to be possible because it's all not one piece. Okay, so now I'm going to shift every coordinate 30 degrees to the left. So instead of starting at 0, I'm going to now start at negative 30. Instead of having my turning point at 30, I'm now going to have my turning point at 0. Okay, instead of, so that turning point move, 30, what is that, 30? Yeah, so instead of having the turning point at 30, it now moved to 0. Then I can say, instead of having this intercept at 60, I'm now going to have it at 30. It's going to be the next intercept. This is going to be 30. Then the next turning point will be at 60. Okay, and finally, I'm going to end at 90. Okay, so I hope you see how those chain of events work, right? Every single coordinate, and again, in this case, we only care about intercepts and turning points because that's all we need to draw our graph. Okay, so each thing shifts to the left. So instead of starting at 0, I start at -30. And of course, then it's intercept, turning point, intercept, turning point, intercept. Okay, so now I need to draw this line up because I know that this is going to be a turning point at 2. And then I know intercept, turning point, intercept. So 30 is an intercept. Then I go turning point. So 60, I have my bottom turning point, my minimum value. And of course, at 90 is going to be another intercept. So now we can draw a graph. So turning point, intercept, turning point, intercept. Okay, it's not as perfect, but it's fine. And that's basically my graph shifted to the left 30 degrees. Okay, so now let's make the final change. They want us to shift 1 unit up. Okay, so 1 unit up, that's not going to be a problem. Let's do this. Okay, so they want us to shift 1 unit up. And yes, technically, I could just take this whole graph and move it 1 unit up. So this, of course, is a change to y. So now, again, the same thing applies. Okay, what do I mean by the same thing? Every single coordinate that we worked with, right, is going to shift. Every single coordinate that we work with is going to shift 1 unit up. So we can do that, right? So let us, okay, let's do this. Oof. Okay, that's fine. Okay, so now let's use blue. Okay, this -30, its original coordinate is -30 and 0. Instead of being -30 and 0, it's going to be -30 and 1. Okay, then we had 0 and 2. Okay, 0 and 2 all the way up here. That was the old turning point. You can even see the old coordinate is there. 0 and 2, instead of being 0 and 2, it's now going to be 0 and 3. It's going to be shifting 1 unit up. So this is going to be 3. Okay, so we're starting here. This is like our start point. This is our turning point, right? Then we had 30 and 0, because that was an act. Let me do this. Let me get this back to green so we can see which graph we were working with. Okay, we're working with that graph. Okay, so this 0 and 30 is now going to have to shift 1 unit up, and it's going to be 1 and 30. It's going to be somewhere there. Okay, that's going to be an x-intercept. And we go all the way down. We had this 60 and -2. 60 and -2 is now going to be 60 and -1. Okay, then we had 90 and 0. It's no longer going to be 90 and 0. It's now going to be 90 and 1. It's going to shift 1 unit up as well. Okay, so literally you can take it step by step. Again, like I said, there was a lot of changes that we made here. It's not going to be the case, right? In most likely not, unless your teacher really hates you. Okay, but either way, it's we just practice it, right? And this is how you would make each different change. So take it step by step. Okay, again, you're going to have maybe 2 things that you need to do, 2 changes. So just do it step by step. Okay, so now let's draw in our final graph to the turning point. This is like an intercept. Okay, then to the turning point. This is like an intercept. So that's basically what our final graph would look like. This coordinate here is -30 and 1. This coordinate here is 0 and 3. This coordinate here is +30 and 1. This coordinate here is 60 and -1. And this coordinate here, this last one, is 90 and +1. Okay, so yes, shifting 1 unit up, you're literally just going to shift each and every single coordinate. Again, we only care about turning points, x-intercepts. You're going to shift each of them 1 unit up. Okay, cool. I know that was a bit of a long, tedious process, but I hope that made sense, right? Making individual changes to the graph, right? To draw in different type of sine graph, okay, not the mother graph. Okay, and we'll do another example from a question paper, and you'll see obviously it will be slightly less complicated, but similar concept. Okay, so let's move on. Please, wait, why do we get -1 and not -3? Okay, because we shifted 1 unit up, right? We didn't make a change to amplitude. So you see, that's another thing. Thanks for actually asking that so that I can explain this. If you remember, right, 2, when you have the amplitude of 2 or the coefficient of the entire function 2, right, many people like to remember, oh, okay, if I have 2, then my maximum is definitely going to be 2 and -2, which is true if there's no vertical shifting. But in this case, our graph was shifted up or down. So here we still have technically an amplitude of 2 because we start at 1 and we end at 3. So the 0 to that is 2. Then it goes down. And if we consider from here, okay, from here is +1 to -1. So it's still like an amplitude of 2. Okay. However, because there's vertical shifting, the highest value is 3, but the lowest value is -1. So just keep that in mind. It's not always going to be this case. If there's vertical shifting, it's going to differ. So why is it -1? I'm assuming you're asking, yeah, why is it -1 and not -3? Okay, that's just because our coefficient of this function is still 2. Okay, our amplitude still needs to be 2. Again, from 1 to 3, that's going up. The positive amplitude, and from 1 to -1, that's -2 going downwards. So we're still maintaining that amplitude. The reason we actually have 3 here is because that entire graph was shifted 1 unit up. Okay, so instead of ending at 2, it's now going to end at 3. Okay, instead of ending at -2, it's now going to end 1 unit up, which is at -1. Okay, please let me know if that made sense, or if you're still confused by it. Okay, but for now, let's move on. If you still have an issue with that, I'll come back to it. Okay, let's talk about range change. Okay, so it's just a change to range. Okay, so with the same function, so let's just say you are given a function and they want to know what's the range of this function, essentially. So range change just basically means range change, the change of range from the mother graph. Okay, that's what it's referring to. Okay, and just say either way, the question will just be like you have a function, right? Of course, it's not going to be the mother graph function, whatever it is. So here we deal with the function that we dealt with, except that's going to be 5. Doesn't really matter. Okay, so there's an easy way to determine what is the range of our new graph, right? So you might automatically be thinking, okay, because there's a 2 here, my range is going to be 2 and -2, but that's not the case, again, because of this vertical shift. So the thing for range, okay, if you want to calculate the new range, you must ignore all the values that affect x. And it's basically your period and your change inside of the bracket that affect x, because range are y values. Okay, so since range are the y values, we only need to consider the changes that affect the y values, which is a coefficient in front and an addition or subtraction after the function. Okay, so you can ignore anything in the middle. Okay, anything that the angle is multiplied by a coefficient of the angle, as well as inside, a change inside of the bracket. Ignore all of it because those will be changes to x, and I can prove it quickly, right? Let's talk about the period change. Here's the original function. Let's just decrease the period. Here's a function with a decreased period. Did it affect our maximum and minimum? No, it didn't. It just made our x values more compressed. Okay, so that's thingy, right? Period change. Let's talk about shifting left to right. Yeah, I'm shifting left to right. Okay, obviously it's a bit of a skew graph, so it's weird. But if I shift left to right, my max and min value are not changing, right? My y values, my range, because that's what my range is, my y values, my maximum and minimum values, right? So again, that shift to x or shifting left to right, you can clearly see that's not going to affect the range. However, now instead of having this, if I have that, that's definitely going to affect the range because my maximum and minimum are changing. Or alternatively, if I shift this, if I shift it up or down, it's definitely going to affect the range because I'm shifting up or down. It's going to affect the y value. Okay, so yes, now let's look at this. So how do we make those changes? again, we simply ignore this guy. Okay, we ignore it and we just deal with this and with that. And it's really simple. Okay, so you consider what's the mother graph's maximum and minimum. The mother graph's minimum is -1 and its maximum is +1. Okay, and then what we're going to do is we're going to make these changes to that. So this 2, let's throw it in. Let's throw it in blue. Let's throw this in pink. Okay, this 2 is a multiplication. So you simply multiply the minimum by 2 and you do whatever that is, you add 1. So you do the same thing at the bottom. You multiply the old maximum by 2 and you add 1. If this is -2, you multiply by -2. If it's 3, if it's 4, if it's -1.5, you multiply it by whatever that is, and you add or subtract whatever that change is, and that is it. That is it. It's going to give you the answer for the new max and the new min. -1 times 2, that's -2, plus 1 is -1. Okay, 1 times 2 is 2, plus 1 is 3. And that was proven here when we had a maximum of 3 and a minimum of -1. So you can easily get the range of a new function. Okay, by just following the steps, ignoring the x values and making the change to the maximum and the minimum according to amplitude and vertical shifting up or down. So here, the range of this graph, okay, is y is an element of inclusive -1 to 3. Okay, that's the range of this graph. Okay, and obviously, yeah, this doesn't matter because we had a different one above, but it doesn't matter because we ignore it anyway. Okay, cool. And then again, like domain, remember, we don't really deal with domain, we deal with period. So therefore, period, that just depends. Yeah, the way you get period is you just use this. Okay, you say 360 divided by 3, and that gives you the period of your particular graph. You divide it by the coefficient of that angle. Okay, cool. So that's how we make a range change. Really simple. Okay, let's move on. Let's do some questions. So question number 6. In the diagram below, the graphs f of x, a sine bx plus 1, and g of x, 2 cos x plus b. Okay, so this has 1, 2, 3 changes. So the amount of variables it has actually indicates how many changes it has. They wouldn't put a variable if there wasn't supposed to be a number there, even if it's going to be 1. Okay, but if it has a variable, you can assume that it's going to have that type of change. Okay, so sorry, 1 second. Okay, cool. Right, so yes, in this case we can expect at least 1, 2, 3 changes, and here 1, 2 changes. Okay, so yes, again, of course, we're not getting a mother graph in an exam question. Now I'm going to try and just highlight each graph. So what you obviously want to do first, okay, so let's just see we read everything. I've shown in an interval -90 to 180. So of course, like, remember we discussed that your sine graphs and cos graphs can go on forever. Like I said, like, okay, this can go on forever and ever and ever, whatever, right? But of course, in the exam, like, we can't deal with a question that can potentially go on forever. So they reduce our interval, okay, from there to there. Okay, in this case, whatever they specify. In this case, they say -90 to 180. That's fine. Okay, so of course, the main thing is to identify which graph is which. Please do not confuse the two. So f of x is this guy. And it's more so important in trig functions, obviously, because, like, for example, a sine and a cos graph could be really similar. Okay, and then we have this guy here, which is g of x. Okay, cool. So we have f of x, we have g of x. Let's look at the first question. Write down the amplitude of g. Okay, before we continue, let us just work through it ourselves. Okay, let us try and identify what changes were made to each graph. So let's work with f of x. Okay, let us work with f of x. This is the one we are going to be working with. No, that's g of x, sorry. So again, because cos graphs and sine graphs can look pretty similar, let's see what we have. So f of x is a sine graph. Okay, f of x is a sine graph that does not have that there was a period change made to. Okay, there was there was an amplitude change made. Okay, there was a period change made, and the graph was shifted 1 unit up. Okay, that's not unknown. We know how much it was shifted up. It was shifted 1 unit up. Now, we didn't even they didn't even need to tell that to us, because we supposed to be able to figure it all out from this graph. So I know, right? And if you want, you can draw your mother graph in pencil. It's not going to exactly help, but this is a sine graph. It could be negative sign or positive sign, right? So this is the positive sign graph. It would need to go to 90 and like 180, right? Because literally that's where the first intercept turning point is, at 90. So we can clearly see that this graph has been compressed because it's so much shorter, okay? And the negative sign graph would do that. That's what we'd see of it, right? So the first thing is, what's easiest to identify is a period change, okay? Out of the two for now, okay? The easiest we can try and identify for now is a period change. Why? Because remember, the period of 360, right, is the entire wavelength of one sine graph. One sine graph should go up to 360 degrees. Okay, so now we can see, what does one sine graph, one full sine graph entail? One full sine graph, we can start here and basically go turning point, intercept, and that ends our one complete wavelength. So we start at 0 and we end at 120. Okay, so since we end at 120, that's right on the side, we know that our formula should be new period is equal to 360 divided by whatever that coefficient is, right? The coefficient of the angle. So now we have values for the new period, okay? And our values are 120 degrees. 120 degrees is equal to 360 divided by the coefficient. Now we can solve backwards for that coefficient. So we can swap these two actually, or take this over as multiplication and then bring the 120 over as division, but it gave me a shock. Okay. Okay, but if you obviously, if you eventually you'll get this 360. Sorry, just give me 1 second. Okay, so like I said, right, obviously you're going to have 360 divided by 120 eventually, and you're going to end up with 3. So that means that the coefficient was what? The coefficient is 3. So now we've solved for B. B is 3. Okay, then, okay, now we can potentially solve for A. Okay, so B is 3 because we can see that it was compressed. So that's one of the easiest things. Like I said, we just determine the total of a entire period. What we can also do is, right, we don't have to necessarily we don't have to even use a full period, right? Just say sometimes you don't have the entire graph drawn. You can even use one step, okay? The distance between the first intercept and turning point. Literally, that's all you need to determine what this graph has been compressed or expanded by, okay, to determine the coefficient of the angle. You literally just need one step, because here we start off at 0 and we end at 30. So one step, because this is from intercept to turning point. Sorry, actually, yeah, it's like intercept because that's normally on the x-axis. Intercept to turning point. All right, that's what this is from, intercept to turning point on the mother graph. Okay, the mother graph step of the mother graph is 90. Okay, and it's the same process, right? Remember, the new step is calculated how? The new step is calculated by saying 90 over the coefficient. Okay, so our new step in this case is 30. As you can see, from intercept to turning point is 30. So we could even use this way. 30 is equal to 90 over the coefficient. And then, of course, we solve the coefficient as 3 again. Same value. Of course, you're going to get the same answer. So like I said, you don't even need to have the entire graph. You just need to have one step to be able to determine how much the graph was compressed by. Okay, so just keep that in mind. That's actually really important, because some questions test you like that. Okay, so we solve for that. Now let's solve for A. So A again is easy to solve for in this case, because what I can do is, so obviously in this case, you can see we start off at 0. Okay, A actually, I forgot to write something. We forgot to go through it. here we can calculate the coefficient. Okay, I'll write it neater. We can calculate the coefficient by saying max minus min divided by 2. Okay, this is a formula that we can use to calculate the coefficient of the entire function all the time. Okay, by simply saying the maximum minus the minimum divided by 2. And we can see that it will work here as well, right? Maximum is 3, minimum is -1. Because it was shifted, you want to know what was the coefficient that it was multiplied by, what was the amplitude increased by. You can say max minus min over 2. Always will give you that coefficient of the entire function, not coefficient of the angle, that's to do with period. Max over min divided by 2. Here we can say 3 minus 1. Keep that in mind. So minus 1 divided by 2. That gives us 4 over 2, which is equal to 2. And we know that the coefficient, our coefficient is 2. Right? We know, here's it here. Coefficient is 2. So that's the same thing we're going to do in this case. Okay. To calculate A, we can simply say max minus min, okay, over 2. So we can basically say our maximum, if we look at our f of x graph, okay, our maximum is here. That's the maximum value. Our minimum is here. Our maximum is 2. Our minimum is 0. So this is going to be 2 minus 0 over 2. And this is essentially going to be 1. So there was no change made to that amplitude. And that kind of makes sense because you can see it starts here, goes to 1, goes to -1 kind of thing. Okay, so that we know now, okay, that A is one of two things actually, in 1 or -1, because obviously if we look at our positive sign graph and our negative sign graph, they both have the range -1 to 1. They both have an amplitude of 1. Okay, if we do max minus min over 2, we're going to get 1 for both of these. Okay, so the way that we have to look out for this is visually, right? This you have to look out for it on the graph, and of course you can see the shape, right? We know that this graph wasn't shifted left or right. Okay, so a positive sign graph would have started. A positive sign graph would have started here and went here and there and there, right? Like this, sorry. It starts off at 0. Okay, that's 1, but normally starts off at 0 and 0, but it still starts off at 0 degrees, and then it goes upwards. But in this case, we can see that this graph then goes downwards. So that tells us it's a negative sign graph, and therefore the amplitude, that's why in this case they are asking for A, because A is not just 1, A is actually -1. And if you are getting 1 for the coefficient, just double check, is it supposed to actually be -1? Okay, so -1. So we've solved for A and B. Right, so that's again, before we're reading any of the questions, we just doing our own like troubleshooting on this question and trying to solve for what the functions are. Okay, because either way, that's going to be like the main part of the question. And again, just using the graph, looking at the graph to try and figure out what's happened to the graph. That's an important skill in this specific section, right? Relating it to the mother graph, always trying to see, okay, the mother graph was like this, what changes were made. Okay, now let's have a look at this. So we know that 2, there was amplitude change. It was increased by 2. Then we know that all that was done here that we need to figure out is P, right? This is a horizontal shift, meaning left or right. Okay, this is a left or right shift. It's a change to X. Okay, it's a change to X, so we need to try and figure it out. So again, you're going to try, okay, so we know that the amplitude is increased to 2. What you can also rule out here now is there was no period change. The period is what? The period is 360. For this graph, there was no period change, there's no coefficient here, and this graph wasn't shifted up or down. So you can rule those out completely. So you know for a fact that your period is 360, your step is 90. Okay, you also know for a fact, right, that the graph wasn't shifted up or down. So it's going to start at -2 at the bottom, it's going to end at +2 on top. Right, there's no vertical shifting up or down, so you can rule those out and deal with look at your graph accordingly. Right, the only thing, literally, okay, of course there was an amplitude change, but the only thing we need to figure out is this change left or right. So it was shifted left or right. So you need to consider, okay, before we even look at g of x, right, let's consider a mother cos graph. So the mother cos graph would start at 1, okay, and then go to 90. No, I forget how it is actually. So it start at 0. You know, to start at 1. Yeah, to start at 1, and then intercept at 90, turning point at 180. Right, that's how the mother cos graph would look. Okay, let's multiply its amplitude by 2. It would start at 2, still go to 90, go to 90 for the intercept, and then go to 180 for the turning point, right? Intercept, turning point. That's how the mother graphs would look initially, the first one I said, and this is how 2 cos x would look. Okay, now it's easy to figure out how the change is. Now, of course, I've drawn this in, we can technically use any point, but nevertheless, right, we know that this graph, it's a mother sine graph. It was not shifted up or down. Okay, so we just multiplied the amplitude by 2. So instead of starting at 1, it was supposed to start at 2. But now there was a change made where it was shifted left or right. So instead of starting at 2, where does it actually start? Oh, it starts over here. So it starts over here and then continues its whatever. All right. So again, instead of starting at 0, technically, sorry, not 2, because this technically also does start at 2 y coordinate. We talk about x coordinate. Instead of starting at 0, it starts at negative 30. So this was clearly shifted 30 degrees to the left. 30 degrees to the left. So again, that was just me relating it to the mother graph. Again, it's supposed to start at 0, but now it's deciding to start at negative 30. Oh, that simply means it was shifted 30 degrees to the left. Now remember, 30 degrees to the left actually means plus 30. 30 degrees to the left means plus 30. Because with x, it works opposite. And of course, this is just 2, this is just 1. We didn't calculate those. So there we've solved for the graph. We know that this graph was a negative sine graph that is reduced by a factor of 3, compressed by a factor of 3. Its new period is 120, and then shifted 1 unit up. Okay, we know that this graph is a normal cos graph that was multiplied by 2. Okay, multiplied by 2. So maximum initially became 2, negative 2, and then shifted 30 degrees to the left because we looked at the graph and we were able to see, like, you need to tell yourself, okay, where was the mother graph supposed to start? It's supposed to start there, and now it's starting here. Okay, clearly there was a shift to the left. That's the easiest way to judge it. Okay, is from where it was supposed to start. You can even use, okay, where was the first intercept supposed to be? Oh, at 90. Where's the first intercept? Oh, it's at 60. Shifted 30 degrees to the left. Remember, each and every point is affected by that change. Okay, cool. Let's move on. Right, let's finally do the questions. Write down the amplitude of G. Okay, so we want to say max minus min. Over 2. Actually, I'm just going to confirm for these, should you be giving the answer from 0 to maximum, or are you supposed to be giving like from the regular rest position? Either way, it's fine. Just use this formula for now, and I'll confirm that. So this is going to be easy. It's just 2 minus 2 over 2, and this is going to be equal to 2. Okay, so the amplitude of G is certainly 2, and we can see it, right? Just multiplied by a factor of 2. Determine the period of F. Okay, the period of F, remember our F graph is this guy. Okay, so the period of F, we know that F of X was, the coefficient of its angle is 3, so it was reduced by a factor of 3. So therefore, we even calculated it there. The period is 120. You can even have a look at it. For one full rotation of this graph, it's from 0 to 120. So that's how we know the period is 120 degrees. Determine the values of A, B, and P. We solved for A as 3. We solved for B as -1. We solved for P as plus 30, not negative, even though it's shifting to the left. Okay, how we solved for those? We did them just now above. Okay, determine the values of X such that G of X is greater than 0. Oh, great, our favorite intervals. Okay, so let's have a look at some intervals with trigonometric graphs. G of X greater than 0. So firstly, this is a function just like y. So this just basically also means y greater than 0. So it's how many marks? 1 mark. It wants to know where this graph G of X is above the x-axis, because that's what y being greater than 0 means. Okay, if you're not so certain about this, please watch the video on functions where we go through that in detail. Okay, so yes, it just basically means where is it above the x-axis, g of x. Let's identify this g of x guy. Again, please remember it's for this specific interval, so we don't have to go beyond this interval. Okay, we don't go before or after this interval. So every single part of this graph that's above for g of x is basically this. So I've highlighted part, I identified. Now I identify start point, end point, and express it in terms of x values. It starts at -90, it ends at 60. Okay, that's it. So I can say x is an element of, two ways of giving this answer. X is an element of, the question doesn't include, so I don't include -90 to +60. Alternatively, I could say x is greater than -90, but less than 60. I don't include again because the question doesn't include. Okay, two ways of answering that. Let's have a look at the next one. F of x is greater than or equal to g of x. Okay, so remember what we know this to mean is y is greater than or equal to y. Okay, meaning one graph is above the other because that's what y is. When y is greater than another y value, that means it's above it. When y is less than another y value, that means it's below it. Okay, so y is greater than or equal to y, meaning where is f of x greater than or equal to g of x, or f of x, if f of x's y values greater than or equal to g of x's y values, which basically mean where is f of x above g of x. Essentially, that's what that means. Okay, so let's go and try and identify the parts of the graph and then express it in terms of x values. So highlight the parts of the graph where f of x is above g of x. If you remember from functions, we discussed that at the points of intersection are very important for this because they change at the points of intersection. What changes when one being above and one being below? So we can identify the points of intersection and separate our graph into different sections. And that's it. That's it for this. So we separated it into section 1, section 2, and section 3. Okay, and in each different section, the one is going to be above the other. So let's identify, we want to know where f of x is above g of x. So f of x is this guy. Okay, and then g of x is that guy. So let's look in the first section. Let's highlight g of x and let's highlight f of x. Okay, let's use green and red. Okay, so let's identify the one above. It's clearly this one, and the one below is this one here. Okay, which is f of x. So we want actually where f of x is above. So this is not the section that we're going to use because g of x is below in that. G of x is above in that case. Let's have a look at this one. Here we can see that in this section, this one is above. Okay, and this one is below. So clearly the green one, yeah, that's why I highlighted in green, the green one is above. And since the green one is above, the green one is f of x in this case. So this is the section that we're going to choose. And then in the third section, it's going to change again. So let's leave that there. In the third section, it's certainly still above gx. So it remains, no, I messed that up. Oh, sorry. Am I confusing the two? G of x is above. G of x is above. Okay, here's one of those examples where, as you can see, where the confusion, I can understand where the confusion from myself is coming from. If we notice, right, even though they intersect there, right, for the entire duration, g of x is still above, which is a bit strange. Okay, but it's not an issue. It's just one of those examples. Okay, even though they intersect for the entire duration, okay, maybe obviously except at that point, right? So that's why we can still separate it into that segment, because at that point none of them are above, they're equal to each other. But even though they intersect, they don't switch. Okay, because g of x is still above f of x after that interval. So in interval number 1 and interval number 2, g of x is still above, but then thereafter, that's where now f of x becomes above and g of x goes below. Okay, so it's basically everything after this intersection point to the right of it, okay, in terms of x values, right? Remember, we always want to relate to x values. So I allocate my start point and I allocate my end point. So I start here, okay, and I end here in terms of x values. So now let me express that in terms of x values. So here the x value is given of m. So it starts at that point and ends at 180. Always don't go further than the interval. Okay, so here we have x is an element of, I include because the question includes. Okay, I start off at whatever this value is. I'll copy it down now. I ended 180 included as well. This is 48,05. So it starts at 48,05 and ends at 180, or x is greater than or equal to 45,08, but less than or equal to 180 degrees. Okay, so that's that question. Please, if you don't understand it, let me know and then I'll try and explain it again. But yeah, basically that just means when one graph is above the other. Okay, so yeah, let's look at the next one. F of x times g of x is less than 0. F of x times g of x is less than 0. So remember we went through these, right? F of x times g of x. F of x times g of x. It's a multiplication that needs to be negative. A multiplication that needs to be negative. So how do you get a negative in a multiplication? You either have a negative and a positive, or a positive and a negative. You either have a negative and a positive, or a positive and a negative. So f of x being negative, what does that actually mean? F of x, essentially what it means is f of x less than 0, which means y less than 0, which means below the x-axis. So we need to identify a part of the graph where 1 is below and 1 is above. That's essentially what this means. We need to identify the part of the graph where on top we satisfy the first one. 1 is above. Sorry, 1 is below, 1 is above. The first one below, second one above. That's how I just did it. And then the second time we do the other one above and the other one below. So let's try and identify. Get rid of all of this. Okay, so now what we know is we need to just also, okay, so the first one we can do is what? This one being below and this one being above. So f of x below. So we can start off by trying to identify the part of the graph where f of x is below the x-axis. Now, if we look for the entire duration of f of x, it's never below the x-axis. It's never below the x-axis. So therefore, in this case, we can rule out this condition completely because it needs to both need to happen, meaning both need to be true. While this is below, that needs to be above. And if we start off and f of x is already not ever below, then that criteria cannot be filled. So we can automatically just ignore this one. Let's move on to the next one. Let's look for the part where f of x is above and g of x is below. Okay, so f of x is above and g of x is below. So this is easy because for the entire duration of this graph, f of x is above. So we need to just identify the part where g of x is now below. And where g of x is below is over here. Okay, but, okay, so of x, f of x above is this entire thing. Okay, but remember, we want the interval for where 1 is above, where f of x is above, and at the same time, g of x is below. Okay, so if we start here, right, if we like, okay, let's follow this graph where it's above, here and here, right? F of x is above, but at the same time, g of x is also above. So that's not true to the criteria, right? So let's keep moving. Like if we consider here, 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 g of x is still above with f of x. Okay, here, here, until we reach 60, where at 60, right? At 60, okay, f of x is still above, f of x is above for the entire thing. And now at 60, g of x starts going below. G of x starts going below. And at that point, we have f of x being above and g of x being below. So all of this falls away. Okay, it's not part of the same interval that we consider f of x being above and g of x being below. So you just have to, yes, identify the part of the graph where it's true for the same x interval. And when we start at -60 and we end at 180, okay, we can see that f of x is above the x-axis while g of x is below the x-axis, and that's exactly what we're looking for. Okay, so that's what we're going to give our answer. We start at 60, end at 180. So we can say x is an element. And remember, we did try for that one. It's just that f of x is never below. So that's why we go to the next one. Normally, you'd go do for both and you can get potentially 2 answers. The question doesn't include, so I don't include. I start at 60. I end at 180. Alternatively, I can say that x is, I don't include because the question doesn't include, x is greater than 60, but less than 180. Thus, between this interval is where the f of x is above while g of x is